Guys, these are your notes that you need to complete over the weekend. We're going to get straight into this. There's some prerequisite skills that I need you to kind of review that you're going to use on some of these problems we have to apply the coordinate geometry to. So I'm hoping you remember a foil method, first, outer, inner, last. I kind of showed an example of that. Or you can use a box method, which I know we've used in class before. So um, number two, the hint I'm giving you is that exponent tells you how many factors of this. So I know I gave you in number one 2 factors of the grouping of x plus 2 and x minus 3, but on number 2, since I'm saying x minus 2 squared, that means I have 2 factors of x minus 4. So that might help you set up your box. It should have the same expression. So try to finish 4. All right. So I need you to kind of recap. We did this last semester about understanding the relationships on the coordinate plane and equal distance, especially if we're dealing with from the origin and if it's symmetrical. So if I gave you, you should draw this on your spiral, following a rectangle, okay? I'm going to go ahead and tell you it's a rectangle. And if it's a rectangle and it's centered at this origin, in a rectangle, we know that the diagonals bisect each other. Now, I know that this, if I was looking at my diagonal from vertex to vertex, it would be equal distance from A to C or BC. So I also know, since this is at the center, I know that the distance between right here are the same and the same here, okay? So if I know that to get to B, I have to go over the horizontal distance of 3 and up 2, then I know my vertical distance up to A has to be the same as 2, okay? It has to have the same height as B. Now, I'm just going to reflect it over the y-axis. Here's my y, here's my x. This is equal distance, so if to the right is positive, then A would be at a negative 3. And I think you already know this, okay? So equal distance. So I know that this distance has a vertical distance for B is 2. So if I go in the opposite direction, that would have to be negative 2. Same thing with my, over here with my D, negative 2. So then all I got to worry about is my horizontal distance, 3. And then we have negative 3, okay? So if we're reflecting, we're looking at opposite. We're still addressing equal distance. So all we're going to do is just taking your understanding of that, and now we're going to have no more numbers on our graph. We're going to have variables. So using that same relationship, we're going to find or give the variables, not making new variables, keeping the variables that are given, and label the points. So if I already know that this is the distance of A, and I'm going a vertical distance of B, I'm just going to do the same vertical distance here, and now I'm doing the opposite. So this would be, yes, negative A, B. This right here should be a negative B, and then we should have negative A, negative B. All right, so hopefully you got that. I'm going to ask you to do that again, I think on 9 and 10. All right, so here's your notes. It just kind of goes over that fact, but we're going to talk about when it's in a when we're dealing with a parallelogram and using your opposite slopes. So you might want to do this with me. I know that if we're looking at opposite slopes, they have the same opposite sides have the same slopes, so they're parallel. So what I could do to find my t coordinate, because I know that right here, this is on the x-axis, so it has to be b0. It has to be, and that's given to us. And I know right here we have CD. So I know that my rise would have to be a vertical distance of d, because that's the y coordinate. And then my run right here would be C, okay? So if I'm trying to get to this point, T, it's going to have the same vertical distance and the same horizontal distance, meaning, I'm going to just show you right here. This is just moved. It's the same right there. So all I'm doing is adding that piece, sliding over, because this is where my B is. I know this X right here is B. Oops, I'm going to do that. Okay, so I know that's B. So all I have to do is add my C part to my T. So our T would literally be B plus C. And then I know it has the same vertical distance, comma D. Okay? So I want you to try that here. Now, I'm going to show you 2 ways using the variables, and we're going to use our relationships with slopes as for being perpendicular. So If they're perpendicular, we should know they have opposite reciprocal slopes. And so if I'm looking at my coordinate A, okay, it says hint, find the slope of OA. OA is this segment here, okay, and I can get to that by having a rise, that would have to be B, and a rise of A, okay. So the slope rise over run will be B over A, okay. Now, they want us to find the slope of OB, okay. If I did not have coordinates there, I could determine the slope by understanding and recognizing right here it's perpendicular. So I know that this segment, OB is perpendicular to OA. So that means it would have an opposite reciprocal. So I would just take the slope of OA, flip it, and change it. So flip would be, and a change would be negative A over B. Now, on this side, you can give me the coordinates based on the distance they gave you. So I didn't want you to try to see if you can give me the coordinates of B and D. Okay. Hopefully, you see it has to be rise over run, or my horizontal distance, and my vertical distance. Hopefully, we got negative 2, 3, and then we have our negative 2 to 0. All right, so you can determine this actual value of OA, its slope, by using what we know about O and D. Okay, let me pause this real quick. All right, so we're going to use that relationship, see if we can find the missing vertices for W and Z. You want to pause the video or just try? I'm going to put them up here. Check your answers. Quick explanation. But since I know that this is BH and this is on the x-axis, then it has to have the same distance. So I know this would have to be B0, and we should see that this would have to be 0H. Okay. All right. This is a square, so we know we have equal distance all around. Right. So we know the origin is here, 0, 0. So this would have to be A0, and this would have to be A, comma A. Again, we have a square, but now it's at the origin. Okay, so the distance between equal distance is reflective. That's what our example 1 was. So if I know this is B, negative B, B, this would be negative B, positive B for W, and Z would be negative B, negative B. All right, so what I want you to do, if you need it, okay, watch this video for help. If not, move on. We can definitely going to check over those. On number 5, it's very similar to example 2, but the parallelogram is now kind of has a negative slope, or it's slanting in the opposite direction. But we're still going to use the relationship. Since I know that these opposite sides are parallel, they have to have the same slope. So that would be rise. Okay. Let's move this piece over here. Rise. Rise over run, right there. And what I want you to know is that distance here is the same here, okay? And so I already know that right here is C, okay? So if I'm taking that piece basically off, because that's the same distance, if you look. Oops, I'm going to bring that underneath. And then I should put it in red. This is our C. Right here, it has the same vertical distance. So that's how they just subtracted C minus A to get to that point. They're subtracting that piece. So think of that. That's C minus A. Then we should see that over here, this is on the origin. This is real easy. 0B has the same vertical distance. And to get to B, we know that that distance here was the A. So this would be A0. It's a rhombus, so all sides are congruent. That means the diagonals bisect. Okay, it's at the origin. So we're going to have equal distances again. Oops, that should be 3 marks. Okay, so I know that 0t, we got r0. So right here, just for equal distance, this would be 0, negative t. And then equal distance, this would be negative r0. Okay. And then for our sausage trapezoid, if it's an isosceles trapezoid, the legs are congruent. Okay. This is centered at the origin. So we're going to have equal distances here. So this is real key. If I know that we have A0, negative A0, if this is BC, then we have negative BC. All right, thank you for taking care of that. If you needed the help, I'm going to do a new video. Just use your playlist to get to the next part.